And I'll grab a... Okay, so I've just got a beaker of water. Phenolphthalein is a base indicator. Yeah, it does. Turns pink in a base. Lithium metal. Yeah. And a steak knife. Yep, steak knife. And tweezers would have been good.
Just use your fingers. It's safe. Don't worry.
Okay. Right. It's rather oily. Okay, so lithium metal. Lithium is a really strong reducing agent. It's the strongest reducing agent that we have, such that, which is why lithium is in pretty much all our batteries. So lithium is in all your phones, etc. It's in cars in large quantities. Yeah. So we should be able to see, right, that it's quite dull in appearance. I don't know if you can see that very well on there. Yeah, see how it's like a dullish grey? And that's because the surface of that piece of metal has been oxidized. So that's lithium oxide is the most likely dull appearance on the outside. So if I then take my steak knife, cut it in half, right? It reacts fairly vigorously. So I don't know if you can see that, probably not. No, it's already reacted. So a freshly cut, maybe I'll do it crossways if I can. It's a rather soft metal, yeah? There we go. Don't know if you can see that. Probably not. So freshly cut metal, you can't really see. Freshly cut metal, notice how it's rather shiny, yeah? So we've got the oxidized layer on the outside. Now, as I'm moving this around, that freshly cut piece of metal is progressively getting dull in colour. Yeah, that's because it's reacting with the air, or with the oxygen in particular around it. So I'm moving, getting less and less shiny as I'm moving on, right? So freshly cut metal, one of the properties of metal is that it's lustrous. So it's hard to see well. You can see like nice little structure there. Yeah? Yeah, well, what's going to happen is it's going to react with the oxygen from the air, forming lithium oxide. Okay, so I've got that there, got a base indicator. This is why we call them the alkali metals. So I've added a little bit of phenolphthalein into my solution. It still appears colourless. As I add the lithium to the water, turns into pink. Yeah? And if we look closely, we can see little tiny bubbles are forming around the lithium. Yeah, and the bubbles that are forming, and if I had enough lithium there, I'd be able to feel it because it's quite hot, right? So it's releasing a lot of heat. So some of those bubbles we see are hydrogen gas. Yeah? Some of the bubbles, there's enough energy at the surface where that lithium is reacting with the water to vaporize some of that water. And just for good measure, let's pop another piece in. What does this tell you about the density of lithium? Not very dense. So lithium is less dense than water. Notice how it starts to react rather slowly, and that's because of that oxidized layer, or that little bit of residue oil that's surrounding it, yeah, is that barrier that's protecting the underlying metal. As it continues to react, it reacts faster, and so I can see that silvery colour once that oxide layer has already dissipated. And then eventually it just disappears. So what I have in this solution now is I've got lithium ions, in solution and hydroxide ions. And the hydroxide is causing that pink colour because this reacts with the base to produce that pink colour. If I was to add an acid to this, it would go back to colourless. Any questions? Yeah. So group 1 metals, highly reactive. Yeah. Highly reactive with water. It's called alkali because it produces hydroxide, produces hydrogen gas. That's the bubbles we see. Yeah. And as we go down the group, we are increasing in reactivity. And on Canvas, part of this Pratt is to watch a series of videos of the other metals within the group. You're actually looking at a group 2 metal, so you're looking at the reactivity of calcium. So there's some calcium in there, and you've got your apparatus set up that's in the back of the book. One of those per group, a little bit of phenolphthalein, and away you go. Okay? Right? Take it away. Lab coats on. And into the Pratt.